Hi, now we're going to talk about another subtopic, which is synapse. What is synapse? Before this, we know that electrical impulse will travel along the axon by electrical impulse in electric form. When it arrives, I'm going to erase this. When the electrical impulse arrives at the end of the axon that we call presynaptic membrane, it needs to be changed to another form, which is chemical, because there is a small gap between the axon and the next dendrite. So these are another motor neuron. This is the first motor neuron and this is the second motor neuron. So when there is a gap, this is a gap between the two motor neuron, the impulse in electrical form needs to change to chemical form. That's what we call synapse. So the one in blue, the gap between the two motor neuron is called synaptic cleft. Synaptic cleft, the gap that happen to be in between. So when we zoom in, this is the gap. This is the gap that we are talking about between the axon from one motor neuron and another dendrite of another motor neuron. So this is what should happen to make sure the impulse or the action potential can be passed from one motor neuron to another motor neuron. It's going to start with this. Action potential, or you can also use impulse, will arrive or reach at the presynaptic terminal or presynaptic membrane. It needs to travel until the end of the axon that we call presynaptic terminal or presynaptic membrane. When it's arrived, it's going to depolarize. Remember the word depolarization. When we talk about the graph, it's happened when the graph is increasing. This is the depolarization phase. So what happened is, it's going to open the voltage-gated calcium channels, which located along the presynaptic membrane. I'm going to draw the channel. So when the channel is open, the calcium channel, it's going to allow the calcium to move into the presynaptic terminal. So the one in circles are the calcium ion that move into the presynaptic terminal. What does the calcium ion do? It's going to trigger or stimulate the neurotransmitter release from vesicles. Inside the presynaptic terminal, there are a number of vesicles. Vesicle is like a container that consists of neurotransmitter. The shape is a triangle in this diagram. So these are the neurotransmitter. Neurotransmitter is a chemical signal. What happens is, when the calcium move into the presynaptic terminal, the calcium going to stimulate the vesicle to basically fuse with the presynaptic membrane. It happened like this. It's going to fuse, look carefully, it's going to fuse with the presynaptic membrane and it's going to release the neurotransmitter into the synaptic cleft. This is the cleft that I've mentioned earlier. Cleft is the gap between the presynaptic membrane and postsynaptic membrane. What does the neurotransmitter do? It's going to bind to the receptor. Okay, we assume there is a receptor on the ligand-gated ion channel. Okay, these are the ligand-gated ion channel at the postsynaptic membrane. Okay, post because it after the cleft. Presynaptic before the cleft. These are ligand-gated ion channels. It ligand because it has receptor to bind with the neurotransmitter. Ligands means it binding with any chemical substances. So once the neurotransmitter bind with the receptor on the ligand-gated ion channel, what happen is the ion, which are sodium and potassium, can move in and out. So what happen is the sodium and potassium ion will move in and out of the postsynaptic membrane. So if you look carefully, the K plus will diffuse up while sodium ion will diffuse in. So the movement is related to the graph when depolarization happen. So more sodium will move into the postsynaptic membrane and it going to cause depolarization on the postsynaptic membrane. So action potential will arrive at the postsynaptic membrane. So the function of neurotransmitter is basically to bind and open the voltage-gated sodium channel. So before it's bind, the sodium and potassium ion is closed. So once the neurotransmitter bind, it's going to open up the ligand-gated sodium channel and allow sodium and potassium to move in and out, and depolarization takes place. So action potential, before this it's here, now action potential arrive here. So it's basically we want to transfer the action potential from one point to another point. And then what happened is neurotransmitter cannot be left in the cleft. So there are some enzyme going to break down the neurotransmitter. If not, it's going to continuously binding to the receptor on the ligand-gated sodium channel. So it's going to be degraded and no more depolarization happen after the action potential already arrived at the postsynaptic membrane. Thank you.